In question 8, we're told the curve C has equation y is equal to 6 minus 3x minus 4 over x cubed, where x cannot be equal to 0. In part A, we're asked to use calculus to show that the curve has a turning point P when x is equal to root 2. The question carries 4 marks. So we can put 4tp for turning point, 4tp dy by dx, the derivative will be equal to 0. So let's go ahead and write y is equal to 6 minus 3x minus 4x to the power of minus 3. I'm going to differentiate this, set it to 0, and go ahead and show that it could now be root 2. So dy by dx, differentiating a constant will give us 0, differentiating minus 3x will give us minus 3, and if we differentiate this term, we're going to multiply down by the power. We've got now minus 4x, and we need to drop the power by 1, which will give us now minus 4. So rewriting this now, dy by dx, I'm just going to tidy it up a bit. We've got minus 3. Now we've got plus 12x to the minus 4. So I'm going to say plus 12 over x to the power of 4. So let's set dy by dx equal to 0. So 0 is equal to minus 3 plus 12 over x to the 4th. I can rearrange and I can say x to the 4th is going to be equal to 12 over 3. So x to the 4th will be equal now to 4. We can take now the the fourth root of both sides, and x is going to be plus or minus 4 to the power of 1/4. If we consider this now is an even power, so we can have a plus or minus answer. So x will be equal to plus or minus now the root of 2. So we can say therefore now p x coordinate, we can say x coordinate is root 2 as required. Okay, so that's what we've done. In part B, we need to find the x-coordinate of the other turning point, Q, on the curve. So we can say that Q will be equal now. We can say Q will be equal to minus root 2. Remember, we're going to get a plus or minus answer if we take now the 1/4 power. Okay, we need to find the second derivative, d2y by dx squared. So let's go ahead and write this just here. We know at this stage that dy by dx is going to give us dy by dx will be equal now to minus 3 plus 12x to the power of minus 4. So taking the second derivative, d2y by dx squared will be now 0. We're going to have now minus 4. We'll have 12x to the power of minus 5. So we can say now d2y by dx squared is going to give us now minus, and that's going to be minus 48 over x to the power of 5. So that's now our second derivative. In part D it says, hence otherwise, state with justification the nature of each of these turning points P and Q. So let's set them in. So what we can say when x is equal to positive now root 2, d2y by dx squared will be equal to minus 48 over now root 2 to the power of 5. This now is going to be negative. We can say d2y by dx squared is going to be less than 0, therefore that is a maximum. So if you want to evaluate that, put that through a calculator, that will give you the answer. We can say when x is equal to minus root 2, d2y by dx squared will be equal now to minus 48 now over, and we're going to have in here minus, and we're going to have minus root 2 to the power of 5. We can say from this now d2y by dx squared will be greater than 0, therefore a min. So what we're going to have then is the following. We can say P is a max, so P is max, let's write a max, and we can say Q is a minimum. Okay, if you want to just evaluate those and give some numeric answers at this stage, you're more than welcome to do so. I've just stated one is greater than 0, one is less than 0, therefore we have now a maximum here at P and a minimum at Q. So just set that into a calculator and just put the actual answer just to show the numeric value. In this case, is bigger than 0 and smaller than 0 in this one.